functions quiz review, and the first part of this lesson was, as it says, to express each relation as a table, graph, and as a mapping diagram. What they're trying to show you is that you can express relationships between numbers in a variety of ways, and they want to know if you can do that. So these ones are given to you as coordinate points. Each coordinate point has an x and a y value. So for making a table like this, really you're just kind of recopying the coordinate point in the table, like this. Then the next part of this would be to graph it. Can you graph points? Well, this means how you move on the x-axis, and this is how you move on the y-axis. So this point says to move left 5, 1, 2, 3, 4, 5, and up 3. So we have a point way out here. This one says to move left 2 and up 1. This one says move right 1 and down 1 here. And this one says move right 4 and down 3. Okay, the temptation would be to draw a line between these points because they certainly look like they would make a line with each other. And they actually do, but the point is that these are the only points that you were given. So you can't assume that there would be other points in the middle of them, or points would go on forever. So you don't want to draw a line. You want to graph just what you were told to graph in this case. And then this is called a mapping diagram. Basically what you would do is list the x values here and the y values here. The only difference is you don't repeat the x's or the y's. So if I look at the x's, I see -5, -2, 1, and 4. None of those numbers repeat, so it shouldn't be too big of a deal. I can just copy them right down the diagram. And for the y values, I'd look to do the same kind of thing. Again, do they repeat at all? I don't see any. I see -3, -1, 1, and 3. So they don't repeat either. It really doesn't matter which way you write them. That doesn't belong there, sorry. I would just say that typically you write them from least to greatest here. And then it says -5 goes to +3, so you would want to draw an arrow from -5 to 3 wherever you drew it. -2 goes to +1, 1 goes to -1, and 4 to -3. So this is certainly one way to draw a mapping diagram. And you can repeat that process for number 2. It's the same exact thing. In a table, you actually list all the values, whether they repeat or not. So if I look at the coordinates, I'm just writing the coordinates in the table instead of like normal. So in this case, you can see the x value is the same for each point. So if I were to go over here and graph that, it looks like I'm going to plot all the points just like this. And again, because these are the only points I'm given, I can't draw a line through them no matter how much it looks like I should. Okay, over here on the mapping diagram, remember I said you don't want to repeat any of these values, so this is going to be kind of weird, but the x value, the only one is a 4. Because there are no other x values, and we don't write them over and over again, so we write 1, 4. And then the y values go 0 through 5, so I need to write each one of those in here. The weird thing is to draw the mapping diagram, I need to draw arrows from the 4 to each number that it would map to. Something like that. And if you were looking at this, you know, later on we're going to talk about is something a function or not. The first one actually is, because if you look at all the x's, none of them have more than one arrow coming out of them. It means that -5 only leads to 3. And the same thing can be said for each one of these numbers, that they only lead to one y value. That's a function. But in this case, you're talking about 4 leading to multiple values. That is not a function. Functions are when you have an x value that leads to only one y value. Sometimes it's said as an input leads to only one output. So with that in mind, then let's go to numbers 3, 4, and 5, where the plan is to say whether or not it's a function or not. So if you look at this question, right, we'll do the domain and range in a second. Look at the question. It says, is this a function? Well, I would say no, because of right here. So the answer to this one is no, and it's because the -2 leads to more than one value. So let's go to the domain and range part of this then. Domain is literally a list of the x values in order from least to greatest, and it's written like a set when you actually have numbers like this. And in this case, there are no repeating values, so we can just write all the x values down. And the range is the y values, and again, least to greatest don't repeat any numbers. And in this case, there are none that repeat, so we're done. I'm going to skip over to number 5 for a minute because I think it's in some ways very similar to number 3. The question again is this a function? Well, here, a way to tell this one, a shortcut way, we talked about it is, do any of the x values repeat themselves in this table? What that means is, if you look at it, 8 goes to 8 as a y value, and that's it. 8 doesn't go to any other possible y values, and the same can be said for each one of these numbers. So in this case, this is a function, yes, and you could say because x's don't repeat, each x only leads to one y value. So the shortcut way to know that is that the x's don't repeat themselves. But the actual principle is that the x's don't lead to any more than one y. Again, for domain and range, the domain would be a list of all the x values from least to greatest, so we sort of start from the bottom and go up. In range, it's the same thing, don't repeat. Okay, if you look at it here, right, I have 2 8s, so I won't write 2 of them, I'll only write one of them, and I have 2 6s. So when I do least to greatest, I'm going to do 4, 6, 8, because I don't repeat the 6 or the 8. Okay, and finally the last one, number 4, is talking about whether or not this one is a function and do a domain and range. So we have a couple different ways to answer this thing. But for the function part, I'm going to say yes, and I'll show you why. Because if you draw a vertical line anywhere on this thing, it only touches the line, your graph, once. That's what a function does. And it's the same thing checking a graph as all these other ones. It tells you that the x's only lead to one y. For example, if I say x is 2, and I go to the graph, I see 2, and I trace it up and go over, and it is 3. And that's it. There are no other possible values. So you can just say that this one passes the vertical line test. If it fails, it means the vertical line touches the graph more than once. In this case, since it passed, it is a function. We can do domain and range, but we've got to do them a little differently, because remember, a line represents like an infinite number of points, all the points in between, not just the ones that are easy to see. So we have to give a domain and a range that are based on inequalities like this. Notice we use x for domain and y for range. But the difference is that here, domain is how far to the left did it go. Well, we can see that it never gets past this spot, which is 0 on the x-axis. So the lowest it goes is 0. And if I look at the range on, or excuse me, the domain on this side, the farthest it ever gets is to right here, which is 3. So then I look at the range, which is up and down on the y-axis. What is the lowest it ever gets? Right here at 1, and the highest it ever gets is 4. So that's the range. So when you have a graph that is continuous, that it has a line like that, you're going to have to express domain and range in a notation like this, as opposed to listing all the numbers like we did in the other ones. Alright, so that's kind of the first part of functions, being able to write them in different ways, and also to be able to tell whether a graph or a table or a mapping diagram or even a set of points is a function or not, and to be able to list their domain and range. So it's kind of a lot of stuff, but I think most people don't have too much trouble with that. So let's go on to the next page of this, where I think there is some difficulty, probably the hardest stuff on the test. This was on writing functions. The goal here was to be able to write something in a function notation. So if we look at a problem like number 1, it says determine the relationship between the x and y values and write an equation. Well, what's nice is to shortcut these, you can always say your equation is going to start with y equals. And then it's a matter of what happens to x to give me my answers for y. So if I look at this x coordinate and I see -4 and y is -1, well, the first thing I would try to say is, can I just add something to -4 to get -1? And the answer to that is +3. -4 plus 3 would be -1. But I also try it here to make sure it works. -3 plus 3 would give me 0. That's good. -2 plus 3 would give me 1. That's also correct. And finally, -1 plus 3 would give me 2. So what I'm seeing here is the pattern is that each x value gets 3 added to it, and that's how I get the y value. So what I'm saying is, how do I get y? Well, what this equation would say is y is taking x and adding 3. And that's the equation for that. So you're trying to identify a pattern that you can use to write an equation. So we'll start number 2 with the same idea, but number 2 is a little tougher. If you try just the adding thing, if you look at it, it looks like you add 1 here, add 2 here, add 3 here, add 4 here. Well, that's a reasonable pattern. The problem with that is that there's not really much of a way to write that as an equation. So we have to try something different. If, for example, like if they all said +1s, then I could just write y equals x plus 1. But it doesn't say that. Your thing has to work for each number. So the next thing I try to look at is maybe there's a pattern to multiplying. Well, if you notice, if you multiply x by 2, in this case 2 times 2 would be 4, and I would have to subtract 1 to get 3. Over here, so I had 4 minus 1. If I multiply x by 2, that's 6, and I subtract 1, I get 5. So if you can see what I'm doing here, I'm taking x times 2 and minus 1, and I get y. Let's see if that pattern works the whole way. 4 times 2 would be 8, minus 1 would give me 7 again. 5 times 2 would be 10, minus 1 would be 9. So it looks like what I'm doing is I'm multiplying x by 2, and then I'm subtracting 1. Well, usually when you're talking about taking x times 2, you wouldn't write x times 2 or x2. You usually write 2x. So I took x times 2, and then what did I do? I subtracted 1. So again, if we read this equation, we're saying we get y by taking x times 2 and subtracting 1. And that's how we get every y value. So we're going to combine this idea of using patterns to write equations with the idea of functions and independent and dependent variables. So when you start getting into real-world problems, independent and dependent variables and stuff like that, usually what happens is you don't have everything written in y's and x's, which is like a generic way of writing an equation. You have to write it in terms of the variables that would make sense for your problem. Like in this case, we're talking about ice cream sales, so maybe we would use I for ice cream or something, or S for sales if you wanted to. But then we also talk about temperature, which I guess we could use T for temperature. So the question is which one is independent and dependent? Well, the simple way to answer this is dependent variables depend on something else to figure out their answers. So if we go back up to number 1 for just a second, we might say that y depends on what you put in for x. So in this case, y is the dependent variable and x is independent.